Good morning, everybody. Welcome back to the SAICE Knowledge Trailblazer, where we look for innovative, interesting, and exciting civil engineering topics to share with you. Please like this video, give us a thumbs up, subscribe, and turn on notifications so you will always get the latest videos as they come out. So I'll be starting a topic on building information modeling, or more commonly known as BIM. So today's discussion is on the benefits of BIM, more specific to the civil engineering industry, obviously. And to this purpose, I'm joined by Doug Ackerman, Technical Director of Digital Engineering at WSP Africa. So he has completed quite a few BIM projects for clients all over the world. And today he'll be giving us a pragmatic insight into BIM and take us through a model so that we can see how it works and where the benefit lies. So without further ado, over to you, Douglas.
Thanks, Riaan. Good morning, everyone. I'm going to use a format for this session of describing or talking through projects that we are currently delivering in the BIM space, and using that really as an illustration of what the benefits are and also where we need to be as an industry at the minute with respect to where the rest of the world is moving. So right off the bat, I just want to mention that BIM, as we know, is building information modeling. I'm sure most are aware of that and what it entails. So not to bore everyone, but just in brief, it's the process of producing 3D geometry of engineering designs and putting data into that geometry, which could describe its performance, its specification, or it could be identification data that gets used downstream from post-construction phase into operations and maintenance. So in a nutshell, that's kind of what it is, but it's a paradigm shift that we've embarked on more than 10 years ago, and where we are now is an advanced form of that philosophy, and that's what we're going to see now in the project. So instead of using the term BIM, I'm going to talk to digital engineering. I've always seen BIM as an acronym which seemed to be building centric, but and I know we use the word building in a verb sense now, but that seems inappropriate actually just by default. So for me, digital engineering really describes what we're doing. We are taking engineering from a legacy workflow, from a legacy process, into the modern space of digital delivery. And that's through the full project lifecycle, and that's through all project phases and through each aspect of the design and construction process. So in order to achieve this philosophy or this new domain of digital engineering, we need future-ready teams. And what that really is strong digital engineering leadership around a core of technical skills, which is the combination and marriage of engineering and software. You can't divorce the two. So we really need digitally capable engineers, and together with that, we obviously need the correct hardware and software, IT systems, infrastructure in place to support this new domain that we play in. And there's a range of tools really that fall in this space. And as Riaan mentioned, I'm talking specifically in transportation and infrastructure sector, which is the greatest emerging space at the minute for this. BIM in buildings is quite mature already, and we're seeing those types of technologies being mature. In the T&I space, it's a different animal completely. And there's a range of tools, and we're always at the mercy of the governing authority or approving authority, which is often let's say a provincial or national government institution in various regions, and they've got delivery methods that are defined. And these project examples will talk to that, but this is just a snapshot of the type of tools that form part of the toolkit in a digital engineering delivery. So BIM or digital engineering is not one tool, it's not one platform. We've heard this being said a lot, but it's a workflow, it's a range of things to get you from A to B. The project that I want to illustrate first off is the Orbital Expressway, which we finished a few years ago in support of the UAE business of ours in delivering this 120-kilometer long type freeway scheme, a multi-billion-dollar scheme, a full BIM delivery on this. The client approving authority is a roads authority in Qatar, and they are invested in BIM technology or digital engineering, and to that end there's a strong requirement of contractual deliverable for what you see now. So that's important to note, because what I'm getting at is if you're not geared for this, these types of contractual deliverables are now pretty much default on any large-scale T&I project, international projects. So being geared for this is an imperative, and yeah, to that end, we've learned a lot, but I'm going to share some of these examples with you. So Orbital Expressway, very complex roads type modeling. It is important to have the correct BIM technology in place. For this we used Civil 3D together with what they call a custom subassembly, which is an advanced type of cross-sectional template that adapts to different conditions, because these types of complex freeform geometries require an advanced type of corridor modeling, and this is the type of skills development and cross-skilling that we had to implement in our teams to move from the old way of working into this modern way of working. So KBR, the approving authority, required that we deliver these 3D models both in a native Civil 3D format and in a federated Navisworks type format. That's not just for roads, that's for what you can see on the screen now is 3D utilities. So there's a range of utilities in the right of way. All of these have to be modeled in 3D, designed and analyzed within Civil 3D together with some add-ons for hydraulics, and it also includes other utilities that are not traditionally in the civil space, but we also had to model and take into consideration, which is fiber, telecoms, electrical utilities, etc. Bridges were also part of the mandated delivery, and they wanted a high level of detail type bridge geometric delivery, and modern digital engineering workflows had to be employed for that. And the end result really was, and this is where it differs from what we used in the old way of working, the drawings are not the deliverable. There are drawings being produced from the BIM models. I think we're not yet at a point where we are not producing drawings anymore. There's still need for the 2D output, but in terms of checking, vetting, approvals, engineering approvals and engineering coordination, these are all on a model-based review process. So all the models come together in what's called a federated BIM model. It's simply that. The term federation just means bringing everything together into one, and then all the components are clash detected against each other. And once we clash free, we can get, or we can then initiate an approval process, upon which other types of visual checks and engineering checks are done by the client approving authority. So we're not dealing with markups on drawings anymore in that type of process. This is a full model-based approval system. Okay, so that was one example. The next one I want to highlight is a project that we're busy delivering in between Dubai and Abu Dhabi. Is 450 kilometers of new rail line. That is for a client called Etihad Rail, and the sheer scale of this thing means that generative design becomes an imperative. So you'll hear that term a lot in digital engineering, but it's really where you start taking away the amount of let's say a recipe-based design, where as a human you would, or as a person on the project, you would be doing kind of decisional logic in a structured way. If you can build that into an algorithm, then you can allow the computer to make thousands of iterative decisions rather than one doing it yourself. So it takes away human error, it takes away countless hours, and you get very rapid output. And it also is very adaptable to change. So if in this case the parent rail alignment changes, then everything that develops outward from that alignment is automatically regenerated. So in this case, for the entire formation of the rail and all the lineside access roads and everything on the outside of that, what you're seeing here is a generative model that's generated automatically directly only from the vertical and horizontal alignment from the parent rail string. For utilities, same thing as the orbital, which I've just mentioned. This Etihad rail project has a range of utilities in the right of way, both existing and new. And yeah, being a brownfields application, clash detection between new and existing, between existing utilities and bridge foundations, for example, you can see on screen there's quite a few clashes in that respect. So it's the full 3D coordination that follows on after generating all of this 3D geometry. In this case, Civil 3D was used as a BIM platform. So one has to build all these components first into libraries and then starts the engineering process. And as I said on my first slide, this is the combination of engineering and software. So we don't divorce the BIM process of generating this geometry from the engineering process. This is engineers doing digital engineering directly in a model and analyzing and sizing elements on the fly. As mentioned, 2D outputs is still a requirement on all of our projects. It's only really in the Nordics that they are now having their first foray into infrastructure projects where there are no drawings, even part of the tender process, and models are now the deliverable. We're not there yet. We will be there, but at the minute we run a hybrid approach, and drawing output is still really important, and ensuring that these drawings are derived directly from BIM models with the least amount of manual intervention is an imperative. In fact, on this project, it was a contractual requirement that all annotation is derived directly from model data. In terms of bridge and analysis and design, we've on this project employed an advanced linear digital workflow, which enables us to do analytical models directly from BIM models and to round trip data in a seamless way between the two. And then obviously with drawing output being derived directly from the BIM model, what you effectively have is an elegant linear workflow. This is a huge departure from an old way of the legacy way of designing and detailing bridges. And we found massive productivity gains in doing it this way. And it also has the adaptability of adjusting a bridge geometry in a semi-automated way if one chooses to realign the parent rail string, for example. So as with the earthworks, you have a high degree of dynamic interoperability with this type of workflow, and hugely beneficial in that respect. What's also hugely beneficial is the ability to do automatic quantity takeoffs directly from a model, so you can link a BOQ directly to model environment, and one can really look at design iteration in terms of cost implication, and in terms of finding optimal solutions. You really would be hard pressed to beat this type of workflow, and it's certainly light years better than the legacy way of doing bridges. Same thing on Etihad Rail, bringing everything together in a federated model is a part of the design review and approval process together with the client. And this is just one example of earthworks coming together with utilities and bridges. Just give me a second. Yeah, sorry. Okay. All model elements coming together, all disciplines coming together, full clash detection process, also in a cloud-based issue tracking system. So if I go in here as an engineering manager and I see there's some kind of issue with the coordination, I can pin the issue directly on the model, and it stores it in a cloud-based repository whereby it's actioned to a person, and that becomes an issue register that can be referenced during coordination meetings and provides a track record of how issues are identified and closed out by the responsible parties. So that's Etihad Rail. It's a prime example of how digital engineering is mandated from the client side on these mega infrastructure projects. And again, if one's not geared for this, then these opportunities are not possible to take on. Another example that I want to talk to is a mixed-use development that we are busy delivering in the Seychelles. And for this project, also it's a full digital engineering application across multi-disciplines. So every discipline that you would have on this type of commercial, leisure and hospitality sector project would be your structural, and then civils. Civils would comprise bridges too. It would comprise civil structures that are inherent to the civil infrastructure. And then you'd have also roads, pavement engineering, drainage, both for the on-site and off-site components, foul sewer, water, all the different utilities, all these things falling into the civils umbrella together with bulk earthworks in a 3D type of modeling process. And then MEPF, so your mechanical, electrical, your wet services for the buildings, fire reticulation. So all of these disciplines delivering into a 3D digital engineering workflow. On the civil side, because that's the focus of today's presentation, another key benefit of working in the 3D domain is the ability to do hydrology in 3D as well. So what you see here is a time lapse of a floodline simulation. Being in the Seychelles, which is a high rainfall region, this is really important to understand what happens in a 1 in 100 year storm, for example, and that's what we see on screen in the simulation. This becomes possible due to the fact that all the roads, all the platforms, all the earthworks is being modeled in 3D, enabling these kind of analytical technologies. Further to that, within the civils umbrella, typically in South Africa, and I realize this is a project abroad, but South African kind of approach is applying here. Civils is responsible for roof water drainage. And this is where BIM technology such as which Revit offers for doing everything that's on or within a building is really beneficial. I mean, you can see the range of utilities or the range of different services that exist within the ceiling void and above the roof slab. In this case, you can see the amount of coordination that could be required, and why where the benefit lies in modeling in 3D and being able to produce clash-free models for construction. The last thing you want to do is fix clashes on site during construction. That's where both project owner and project team start incurring huge cost, and there's a lot of waste. And what we're trying to mitigate is ensuring that we build these virtual representation of what's going to get built upfront, where change is cheap. For subsoil drainage, also an aspect that falls under the civil engineering umbrella, typically for these types of mixed-use developments. And in this particular case, we've employed Revit for this purpose because it's close to the building structure itself and requires us to be able to see ground beams, piles, etc., the building structure in a 3D space in our authoring environment, where we are actually modeling these pipes, so that we can have the most effective way of designing in context, really, because that's the ultimate goal here, is to see the full context and not to deliver something that's clash-free and fit for purpose. For drainage design, as I mentioned, that also falls under the civils umbrella, but it's really moved from a very kind of rudimentary 2D legacy type of approach to full 3D parametric modeling using Revit in this case, but together with Civil 3D and other types of analytical engines for not only the generation of the geometry of these types of bridge structures and culverts and crossing culverts and other types of civil structures, but also so for analysis and geometry. So it's really down to producing optimal designs that are cost effective and are really fit for purpose. We can simulate, the full hydraulic behavior of the structure and see a result which means that we've done proper due diligence in ensuring that this thing will withstand whatever it needs to. I want to quickly touch on 4D simulation because this is something that is becoming very beneficial or is very beneficial to our industry as well. And that's when we talk to these federated models, and we now add the element of time into each model element. So this is a time-lapse example of the Mercedes-Benz SA plant that we were involved in East London. And this was a brownfield construction. So the existing plant to the right of this image was still in operation, obviously, whilst this extension was being built, the new body shop. And this structural 4D simulation illustrates how this precast structure is assembled over time. These types of simulations are proving invaluable in conveying design intent and program to all stakeholders on the project, the contractor, the client, the QS. This is really beneficial technology, especially in brownfields, as mentioned, where you've got scenarios that existing operations need to remain uninterrupted, or that the impact on existing operations needs to be carefully considered. For mining applications, this is really also beneficial, and we've got example projects where we're doing 4D. The other type of simulation is 5D, whereby you add the attribute of cost into a 4D model. So then you can start seeing not just how a thing is built, the model development over time, but also what the cost or the cash flow looks like in the same sequence. All of these type of simulations are linked to the project program itself, whether it be in Primavera or MS Projects or an Excel sheet for that matter. We can link it directly so that if the program changes, the 4D simulation will automatically update. Then I want to mention citywide BIM. So often when we think of BIM, we think of a building and perhaps the infrastructure around that building. And we've been doing that for a long time, and we know how that works. And as I mentioned, that's quite a mature type of workflow and technology. But when you start thinking broader, the notion of a citywide BIM, so in this case, we are looking at a model that we've built, which is more than 25 square kilometers in size and covers an entire city in Trinidad and Tobago. And it comprises all the infrastructure that's existing. It shows the principal infrastructure of what is being proposed. And this starts becoming a very powerful tool for in-context conceptual design of massive urban schemes. In this case, an urban regeneration type scheme. This really illustrates the power of the technology now. In this case, there are more than 150,000 buildings in this model, and the single model is handling many gigabytes of data in a quite effective way. And obviously, once you start adding more metadata into this model, you can provide other kinds of analytical output, especially when you're looking at citywide schemes. So having spoken about federated models, I thought would be a good opportunity to go into an actual live federated model. This one is in Navisworks, and it's of the mixed use development that I spoke to in the presentation. So yeah, you can see all the civil elements coming together. In this case, the topography together with roads and earthworks, all 3D modeled within the surface model, coming together with, in this case, the architectural buildings with structural models too. And in doing that, you can actually see then how the foundations of the building, if we go underneath, relate to, let's go to an area where there's piles, how these ground beams and piles then relate to the actual planned bulk earthworks profile. So it's just an illustration of these coming together, and also with utilities in place as well. So if we go to, well, let's look at a bridge first. So yeah, you can see a bridge structure in context together with the top of final, we call it the FG, finished grade surface. And if I hide that, you'll see the bulk earthworks profile below that. And underneath all of that, you'll see the bridge foundation system, the abutments, these wing walls, gabion walls, etc. All this red stuff that you're seeing here is, let me just unhide the topography again, is setback lines from environmentally sensitive areas and water courses. So if I highlight that, let me try and grab one. Yeah, this blue type of line, when I click it, it turns blue. That is a setback line. Where that becomes important is understanding how buildings relate to buffer zones and things. So you can see we couldn't cross that line, and this allows us to coordinate that. If we zoom in here on the main hotel area, you can see how for example, the workspace of the bulk earthworks datum surface has been modeled such that this highlighted retaining wall can be installed, for example. So these are just illustrating some of the coordination benefits really of working in this kind of model environment. Coordination between earthworks, structure, and utilities. You can see here are some sewer manholes, and there, for example, is a sewer line. And here I might say, okay, the depth of cover there doesn't look adequate. And that's the benefit of this. You wouldn't necessarily see that on a drawing directly if you were to open a drawing. You'd have to go and look through profile views and all of that to get down to its viability or suitability. So that's one example. Another one which I can show you is a development which we've done in Johannesburg, the Fourways Mall expansion project. This one had a lot going on, and it's a good one to illustrate in a federated model, because what you see here in the blue is so this was a brownfields project. It's an expansion of an existing mall, which is complete. I mean, you can go there today. The blue is an existing building which was laser scanned using LiDAR technology, both aerial, terrestrial, and mobile-based LiDAR. Very high detail point cloud is produced, and then they call it feature extraction, which is a process of turning a point cloud into 3D geometry, is undertaken by the surveying team. And what we get as a deliverable from the surveyor is the blue, a full geospatially correct, highly accurate 3D model of the existing building. And you can understand why that's necessary if you consider this new bridge flying over here between the old building and having piers right next to it, and new planned parkade structures such as the orange. So very constrained, tight spaces, and then under all of that, all the utilities as well, passing through and in between the piles and the ground beams and the foundation system. And then below all of that, you can actually see the rock profile. So we've got underground strata being modeled. We've got above ground existing being laser scanned, high fidelity models being provided to us, if it's properly specified, obviously. So it's in collaboration with surveying teams. And then we've got new above ground models, being generated using 3D technology together with all the data that needs to be on these parts so that they can be used for whatever purpose. This was a good example of that. If you look at bulk earthworks versus structure, also very complex. You've got the workspace, as mentioned on the previous example, these kinds of workspace voids that are needed in order to install, in this case, it's underground delivery trucking tunnel system. Yeah, so this is an example of foundation coordination versus earthworks. And then if you look at services and utilities, it gets quite complex when you look at it in a federated model because there's a lot going on. This was one of the first, or one of the very few precast structures for retail development. So this thing was put together like Lego blocks. All these parts were made across the road at a production line. And this is where BIM technology is really beneficial, because when you're dealing with a precast structure, penetrations are not as simple. You can't do them during construction and say, oh, it's fine, I'll just core a hole through the floor through a typical in situ type of floor in this, or a coffer slab type application where it's easy to core through the thin part. In this case, these floors are pre-stressed, a precast elements that cannot be cored. So coordination of services, you best get it right before construction, otherwise serious problems. So this was kind of an imperative really to have this level of coordination, but you can see the range of things going on in this model. It's quite a lot. Yeah, so that's just a quick live demonstration of how a federated model looks within this environment. As mentioned, we can clash detect, we can see things in context, both new and existing, and we can action those clashes out to responsible persons and track the resolution of the clashes. So we've got a full history of what was fixed by whom and what the result was of that.
No, wow, like, yeah, this is some quite impressive projects that you've got going. So I just have a question. So more than what we've seen here today, are there other benefits regarding BIM for the industry that you'd like to mention?
Yeah, so if we think of all project stakeholders, I think BIM offers significant merit to everybody involved in the project. So I think the client benefits probably the most. I mean, at the end of the day, less waste, clash-free models going to site, less issues on site. Any kind of issue on site might have a program implication, it might have an abortive cost implication, and someone has to pay for that. So if it's a consultant error, the consultant has to pay. If it's something contextual that couldn't have been avoided, then the client has to pay. If it's a construction error, the contractor has to pay. So if you just think of those costs on the project, by having a clash-free model and having a high level of detail virtual representation of what you want to build before you start building, means that you can, in an ideal situation, you can avoid all of that. We still find that, there are certain unknowns, especially in the civil space. We don't often know what's going on underground. We can do various kinds of scans and things, but there are unknowns too, and those can't be avoided. And that is where BIM also offers benefits to both to all project stakeholders, which would be its adaptability to change. So if it's set up correctly, then a change, for example, from a bridge being piled or on a pad footing because of one discovering different conditions once you open up the ground, potentially, that kind of change one can do way more rapidly with a modern engineering workflow, thereby having a lesser impact on program and at the same time offering dynamic quantity takeoffs and remeasurement to the QS. So I think there's huge benefit across the board. Other benefits I can think of is the quantity takeoff. So in the old legacy way that QSs would measure up from 2D plans, often very crude measurements with not a very high level of accuracy, especially when it comes to measuring volumes, for example, which is almost impossible. I mean, there are first principle ways of doing it, but it's hardly accurate. We see huge errors happening there. So now with the BIM digital engineering type workflow, you can, if it's set up correctly, you can at the push of the button get a full BOQ output, which is greatly enhancing the QS role. You know, they can focus on other things, and we can give them quants that are to the decimal accurate. Other benefits which I've mentioned already is that the design itself, apart from it being clash-free, hopefully, if it's done properly, is through rapid iteration and built-in analytical capability is closer to being an optimal design solution than when you're using a legacy approach. So in the past, change comes hard. People tend to try and do a first time right, and it's hardly optimal because there isn't time to explore many iterations because it takes too long. And with this type of workflow, as mentioned, the dynamic relationship between elements, the ability to analyze and size elements is producing projects that are more budget friendly, and also less surprises for a client later on downstream with budget overruns, because you've got a more accurate baseline to work to. So that costing is accurate. It's not a half a thumb suck type thing. And we know for our relationships with clients as well, you want to show them savings. You don't want to be showing them budget overruns. So yeah, there's so many benefits. I mean, that's just touching the surface of what this technology offers us.
And tell me, from the client obviously has a lot of assets in this case, or what you in essence are building is an asset for them. Is there any way that they can kind of extract what you're doing and kind of have an asset register?
Absolutely. So that's the big driver actually when we look at these projects that I just showcased now. The real reason why these end clients are wanting or mandating digital delivery with a full document called an EIR, an Exchange Information Requirement document, which is part of the ISO 19650 BIM, International BIM Delivery Standard. That document describes what the client wants to do with that model post-construction. So we're talking operations and maintenance here. And at the minute, what that looks like, and there's, you know, the term digital twin gets thrown around a lot. I don't think there's nothing right now that offers a digital twin holistic solution. But what we do see is clients in the mining sector, in the public infrastructure space, they want to absorb the 3D model with its metadata into an EAM, an enterprise asset management system, such as IBM's Maximo, which is the most widely used one. So to do that, that EIR document describes the kind of data that needs to be appended to each model element for it to be absorbed into that system. And that's the only focus right now. There's less focus on geometry. The focus is on the data, and they want to be able to do operations and maintenance. So they want to be able to identify an element, and that identifying attribute must tell them a lot about the element, where it is, what its purpose is, etc. And for that, we often use a system called UniClass, which is an international standard for labeling or providing metadata on elements. In the infrastructure space, it's still maturing. There's a lot left to be desired with regards to attribution, but for buildings, UniClass is very mature already. And for anyone who's watching this and would like to know more about data attribution for operations and maintenance, go just search for UniClass and have a look at their system, which is online.
Thank you. You mentioned something about the approval is done digitally. Can you maybe expand a bit on how that approval process works?
Sure. So these project examples that I just cited are in that domain. So what happens is we federate the models. In other words, we aggregate all the different models into one type of central type file. That file sits in the cloud, or more often than not, meaning these are in BIM, there's this term, the CDE, the Common Data Environment. So that's a key component of an ISO 19650 BIM process, is having a central repository where everybody's data exists, and it should ideally be cloud-based, because we're working with people across the globe, different consultants, different companies. It's not sitting on one person's server. This thing ideally sits in a cloud thing with full permissions, full access. So in doing that, the local models are synchronized to the cloud. Then the client approving authority, often with these projects, they have what's called an owner's engineer or a client representative engineer. And that body, together with a client, would be looking at vetting and approving those models. They go through their process of visual checks, they go through their process of clash detection, and there are various coordination type meetings, usually virtual, where these things are discussed and actioned. And that's the approval process. When that's signed off, and another cool benefit of CDE type approach is that you have digital sign-off. So, there's not a physical signature needed. These CDE environments have approval workflows whereby I submit a model to an approver. The approver receives a notification. They do their review process. They either have comments or they approve. If they approve, then the model is flagged as an approved model and it's moved into a different state, which is usually defined by folders. What I mean by state is it would have moved from being a work in progress model to being a published model. When it's published, it means it depends what the project is. It could mean it's fit for construction. It could mean it's fit for absorption by other consultants into their models. It could mean a range of things, but this digital approval is really key to a modern digital engineering workflow.
Wow, thank you, Douglas. Thanks for taking the time to chat to us today. I think you have given us a very nice practical demonstration of BIM and what the real benefit is and where it lies for each of the stakeholders in the civil engineering industry. I think it's something we need to embrace. It is an improvement, but also the logical next step from the current legacy paper system. Is there any last thought that you want to add?
I think just again to reiterate that BIM is not really a choice anymore. BIM is an imperative, and I say that because primarily in the T&I space, it's becoming a contractually mandated deliverable. And I realize that in South Africa, we're not seeing that yet, but I've worked with numerous global regions and some weren't seeing that, and then all of a sudden it became a requirement and they weren't necessarily ready for it. So I think it's important for us to be ready. It's important for us to be forward thinking. The benefits are there. We understand the benefits. They are substantial, and we need to collectively move forward. We need to help move the industry forward into this space. It's a time of knowledge sharing and helping each other, because this benefits our industry and this produces better infrastructure for the public. The outcome is good across the board. We need to move into this and be ready for this wave that is still coming here, but is already hitting hard in other regions. Yeah, and thank you for the opportunity to present this today. And yeah, I appreciate it. Thank you.
Thank you very much, Douglas. So I hope everyone enjoyed the video and found the discussion topic insightful as we try and demystify BIM for the industry. If you have any comments, please leave it below. Any suggestions on topics, different types of project you'd like to see in the BIM space, or if you just want more information, this can also be arranged. So again, please like the video, give us a thumbs up, subscribe, turn on the notifications, so you'll get all the latest videos as they come out. Until next time, thanks. Thanks, Douglas.
Thank you.